With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello students, I am your teacher for this question, and the question is a sample of pure sodium carbonate 0.318 gram is dissolved in water and titrated with the HCl solution. A volume of 60 ml is required to reach the methyl orange endpoint. Calculate the molarity of the acid. So in this question it is given that sodium carbonate is dissolved in water and is titrated with HCl solution in presence of methyl orange indicator, and it is said that 60 ml of the HCl solution is required. We have to calculate the molarity of the HCl solution. So first of all, in presence of methyl orange indicator, Na2CO3 is sodium carbonate is completely neutralized by HCl solution, and the reaction is this: Na2CO3 plus HCl, it will form 2 NaCl plus H2CO3. It is completely neutralized. So when it is completely neutralized, the equivalence of the sodium carbonate will be equal to the equivalence of the HCl. We can say equivalence of Na2CO3 will be equal to the equivalence of the acid used, and the number of equivalents are given by or calculated by number of moles into N factor, or it is calculated by using the molarity into N factor, as normality is equal to number of equivalents of the solute upon volume of solution in liters. So we can calculate the number of equivalents by multiplying the normality into volume, but here we have to calculate the molarity of the acid. So as we know that normality is equal to molarity into N factor, so we can use molarity into N factor into volume to calculate number of equivalents for the acid. So we will write molarity into volume into N factor for the acid, and equivalents of Na2CO3 are calculated by the number of moles into N factor because its weight is given. Its volume and molarity is not given, so we will calculate this by number of moles into N factor. And number of moles for Na2CO3 will be calculated by the given weight, that is 0.318 gram, to its molecular weight, that is 106, into its N factor. Its N factor will be 2 because Na2CO3, it will give ions as 2Na positive or CO3 2 negative, that is the charge on the cations or anion is 2. So N factor will be 2, and we have to calculate the molarity of the acid, and volume of the acid is given 60 ml. So we will convert this into liters by dividing by 1000, and N factor for the acid HCl will be 1 because it will give H positive and Cl negative ions. So the charge on the ions is 1. Now we can calculate the molarity by calculating this. So molarity is calculated is 0.1 molar after calculation this. So the molarity of the acid is 0.1 molar. The first option is the correct option. So I hope you understood the solution. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.